Okay, so we're going to take a brief timeout from our strip till project, which is, I think, going on schedule anyway. We're going to switch over to adding an air reel, or rather an air bar, to our 925 grain table here. So I picked this thing off at an auction last December. I think it was like $4,000, which sounds high, and honestly maybe was, but it was still about a quarter of the price of what these things go for. This one came off of a 35-foot grain table, so I could only use 2 of the sections. So as a result, I've got this little gap down here. Now, being that I grow beans in rows and not drilled beans, this shouldn't be too big of a problem. Plus, you're going to get some burst of air from this downspout, so it should be all right. It didn't come with any mounts, so I had to custom make my own mounts. That was done last weekend. We got them all mounted up. So now we need to get the air source for this thing. So that's what we have down here. This is one of the Crary, or however the heck you pronounce it, fans. Well, it's an air reel by Crary. But anyway, this is one of the high efficiency fans that go with these. And basically what I did so far is I removed this from the gearboxes, or rather gearbox that goes with this air bar, and I keep wanting to call it an air reel, but really is just an air bar. Anyway, the original gearboxes that go with these, they're a 90 degree, so you have the shaft, your drive shaft. Lord, I need to pick up some of this stuff around here. What you do normally is you split your drive shaft right about here. You put the 90 degree gearbox in, and this gearbox is geared at a I think it's 9.375 to 1, meaning for every revolution of the input shaft, the output turns 9 times. Incredibly sped up. And they were known for being ticking time bombs because, well, two things. One, oil level being a concern. 2, the temperature that they ran at. And 3, just being at a 90 degree like that, it put a little extra undue stress on things. So what I'm gonna do, we've obviously shrunk the bar. We've deleted one section, so we've removed 30%. So if my math is correct, that means I can reduce the speed of the fan by 30%. If I do that, that means I can use one of those pulleys, probably going to be the one closest to us, 18 inches. Slap it on there, and then up here I will run a 3.5 inch pulley on the actual fan, which is going to be mounted in this vicinity. So to do all that, kind of building up the tension here, to do that I need to put a pulley on this fan, and that's why it got split. I was doing this last night. At first I wasn't even going to make a video of this, but the more I thought about it, I was like, kind of a unique project. Maybe YouTube would like to see it. So this is the gear that went into that 90 degree gearbox to begin with. Tried and tried and tried to pull it off that shaft. Been a puller doing it. Heated it up several times, got it glowing red, still wouldn't let go. I do not know what kind of mounting compound they used, but it's definitely indestructible. That part is. So that gear's on there. So we can't reuse that. least that shaft. What I was going to do is simply pull that gear off, slap a new pulley on there, call it a day. Well, we can't do that. Of course not. So what I can do, kind of come in here, I got parts everywhere. But what I can do is re-engineer, oh, there's that word again, re-engineer how the fan works. Or what it's bolted to. The fan isn't really going to get re-engineered, but this hub's going to come off, which is currently riveted onto the fan itself, and I'm going to re-engineer my own hub out of this sprocket and this weld-on hub. The whole thing's going to be done on a 1-inch shaft. The 1-inch shaft is going to be held on with 2 pillow blocks. Come over here, which I've already got one set up here on the milling machine. These are going to be the greasable pillow blocks that we're going to use. One will be attached to that cast aluminum housing out there that we were just looking at, and the other one will be on the other side giving support. So I think I have this all planned out in my head. I guess we're just gonna have to try it and see if this is gonna even work. So let's get started, shall we? This one's probably a little bit closer to where I want to be, so that's probably what we're gonna go with. Shift back out of low gear into high gear here. There we are. Good deal. But at any rate, I'll take the drill bit out of there for time being. So at any rate, what I'm thinking of doing is going to mill out the middle of this plate, leave the outside holes where they're at, obviously. Get one completed, move on to the next, so then I'll have 2 complete identical plates. This one will go on the fan housing, the other one we will weld up into position once the other one's on the fan housing. If that wasn't complicated enough, well, we'll get there. So I will check back in with you once I have both of these done, and probably when we're ready to start welding, to be honest. A couple things I wanted to note how I have this chalked up, or chucked up, whatever you want to call it, fixed up in the vise, is I have 2 parallels in there. I'm just using 7/8 bolts for this. What I like about doing with that method, I guess, well, who am I kidding? It's what I had in the shop. But what I like about it is these can be uptight against the vise. I got 2 flat edges in the form of one side of the hex on the head and one side of the hex on the bolt, or on the nut rather. And then my parallels really can't vibrate out to the left or the right side because of the head and the nut. So it's kind of an unconventional way of doing it, but hey, you work with what you got. So without further ado, I'm gonna get some milling done. Check back in with you here momentarily. All right, so I thought I'd take a moment and show you some proper use of geometry, or rather the lack thereof. So what I've got is the backing plate for that fan casting. Problem here is the bearing pillow blocks that we're going to use, those holes are much too small. So what I did is I centered this pillow block between the two original bolt holes and measured the offset. So this hole in the casting is 0.5 inches closer to center than this one. So what I need to do, if I'm thinking correctly, and I've already kind of etched a little bit of this out, so over here on my plate, to make sure that I'm still centered, is I need to move, well, basically take my drill bit, center it in here, that'll be 0. Bring the drill bit back up, move over 0.5 and down 0.5. That'll move, or rather expand this square to the larger bolt hole pattern that's here, this square. So that can sit on there, that can sit on there, the shaft goes in, and we all live happily ever after. I may even, no, it has to go in there like that. So at any rate, that's kind of how we're going to build this out. Let's see if this works. Okay, so now we're out here on the back side of the head. I'll show you what I've been working on. These were the two plates that we were drilling in there on the milling machine. What I did is I spaced them out with some 1 inch by 3 inch piece of tube. I think it's 1/8 inch wall pieces of steel there. So now we got about a foot separating one of our bearings from the one that's on the back side of the blower itself. I'm not sure why I settled on a foot. It's probably excessive, but yeah, whatever. It gives you plenty of room to get up in there if you ever needed to replace those pillow blocks. Plenty of room to grease, etc. So then I have this piece of steel left over from our air cart project that was even cut at the right angle to have it angle off the front side of the head. This good piece of heavy steel, probably the same thickness. We'll weld some beads on there, maybe even paint it green, but anyway, that's down the road. So now this is held in place, but before I go welding, now it's time to turn our attention down here to the main drive shaft. So I got my 18-inch pulley here on the end. What I'm going to do is go ahead and take this pulley off. This is getting crazier and crazier, I know. We're going to bolt this pulley to that pulley, have a double pulley going there, and once I know where this one comes to rest, then I will put my final alignment in place up here, weld everything into place, get a tensioner on there, and then reassemble everything out here. So it's a little bit further away than it sits a little bit further out than a normal air reel intake will, but whatever. Work with what we got. So we're back at it now. The sun has went down, so moving operations back inside the shop and before I call it a night. So what I've done so far is I've taken the pulley that we're going to put on, the 18-inch pulley, which, in case you're wondering, is one of the drive pulleys off of a 50 series STS combine. I had some perfectly round pieces of steel in the scrap bin, so I grabbed up one of those. This is 14 inches. And what I did is I took that bolt pattern, moved it over to here. Now what I'm going to do is I'm going to take that same bolt pattern and move it to here. Here is the problem that we're facing, and that is we got a hex shaft here. So where have we seen hex shapes around the shop? Nuts and bolts, right? So what I'm going to do, first we're going to fill this void with some nuts. Insert joke, right? I'm going to fill that void, and then we'll drop in our bolt. And then, there we be. Now we are perfectly centered on that pulley. This has already been centered on that. That took a little bit of some fighting, but being that that has an opening for a hub, it made it quite easy. So all I'm gonna do is verify. As Ronald Reagan once said, trust but verify. So we're going to whip out the old veneer caliper here. And we're going to go in. We're going to see if we can't come up with something here. What? 1.15. Right on the dot. Cool. So, again, I was pretty confident that was going to work, but about the time you you just trust, you don't get anywhere. So what we're gonna do is basically go around, touch each one of those holes with the proper drill bit, have it all chucked up down there in the chuck, mark them out on there, take this off, and then proceed to actually drill. The reason being is I don't want to hit my vise. So at any rate, time to shift this back into the lower gear so that we can do that very thing. And it looks like we need to tap it with the hammer. Just tap it. Don't need to get argumentative. Milling machines have feelings too, you know. And we'll put our rough and mill back. Well, that was fun. I think that was empty though. I really need to pick up this shop. I mean, problem is I got 3 different, you know, really only 2 different projects going. All right, so now it's time to start moving stuff around, drill those out. You've seen me drill holes before. I just wanted to show you that little trick that I was using, and I'll check back in with you once I have this complete assembly done. Time for a little update here as far as what's been going on. I probably should have been recording some of this, but you know, I need this. We're out of days. So at any rate, what I've done so far is I figured out where I needed the actual assembly, the blower assembly, in relation to our double pulley that we were constructing. So here's the double pulley. It's on the end of the left drive shaft. Actually, it's centered pretty good. I was kind of shocked. I spun that around, and honestly, you could stand right here and barely see this thing move. So I'll take that for this type of project. The belt will have some give in it. And then, once I had this in place, then I knew I needed to put the end of, we'll just say the assembly, to the left of the pulley itself. So to do that, I had this left over from our air cart project, and basically just welded the assembly to a good solid piece on the header. And once we had that, then it was just a matter of, well, I guess before I welded it, made sure that the small pulley and the big pulley were in line. Just use a piece of flat stock for that. And now I'm getting down into the details. So I know I need to put this blower fan, squirrel cage fan, in here. And on the original one, this was 1-inch shaft that they reduced down to 3/4 and then put threads on the end. I think I'm gonna go with that, because then if I ever need to replace that fan, I don't need to do any modifications. I just give them the part number, on it goes. So since I don't have a lathe, I'm going to take the old assembly and take that to the machine shop along with this shaft, cold rolled steel shaft. Now that's this end. This side of the housing, not much to really talk about. Bolted right on back to the adapter plate. Then the cage goes on and the other half goes on. Not a big deal. What I am... had a little bearing. Anyway, the only bearing I really have bolted in is this one. This one, I'm not 100% finished with this end yet. And here's why. I'm not real happy with how this weld-on pulley came out. It's a little bit warped, and as fast as this is going to be spinning, I don't like it. Plus, this is a 5/8 belt. This is really a 7/8. I was going to try to make it work. I just don't think I want to. So I got to thinking, and I called up my Gleaner expert to see if he could confirm my suspicions, and that was, I thought the Gleaner Fs had a 7/8 cast pulley just under the radiator for the engine, which drove the unloading auger. And it sounds like I'm right. The downside to that is it requires a threaded shaft. He was pretty sure it was a 1-inch. It too might be a 7/8, or rather 3/4. Goodness gracious. At any rate, I'm going to be going over there in a couple of hours, see if he's got one of those pulleys in stock. But that's where we're at. That'll get the drives all finalized, and I just need to throw a belt on here, put that idler on there, and call it a day. So that's where we're at. I gotta straighten up that half of the cage assembly for the fan. It was banged up when I got it. That shouldn't take too long. Just I think it's just the one dent, if I remember right. Yeah, just the one dent that I gotta pull out of there somehow. I'm sure it'll be more fun than I'm giving it credit for. Okay, so it's time to bring you back up to speed. I got the fan back in the housing on the shaft that I had made. I didn't do any of the shaft work or the lathe work rather to get that shaft put together. So there's really nothing to film there. What I didn't film was getting this fan back on there and centered inside this housing. A couple reasons for that. Primarily, I needed both hands and then some, and to concentrate really. But thing to remember is we used these cast self-centering bearings, and as a result, if these two housings aren't perfectly aligned, which, I mean, come on, it's a weldment, for crying out loud. You're always going to have some warping going on, and let's face it, I just made this on the ground. It was close, but not that close. So what I had to do, I went and got the next size smaller bolts for this end, dropped those into the housing and the weldment so that I could move this around until I got this fan pretty much centered, in that it runs as close as it can to this aluminum casting without actually colliding with it. So that little bit of noise you're hearing there is a spacer that's on that shaft, and it's not actually the fan dinging. So I'm gonna take that as a win. Let's start putting this back together so we can get this thing in the field. I think the first thing I'm gonna do is align align our pulley with the pulley down here. See, I tell you guys, I've been sick the last couple of days, and it's all I can do. It's all I can do to be out here, but we're making it. We're making progress. This is the belt tensioner, as you can see. I've got basically some stock John Deere parts, stock idlers off of, I think this came off of a 600 series head. This is off of a 900. They're all John Deere part numbers, with the exception of this belt, which is a AGCO belt, but a fairly common belt at that. So when I go stock belts for my Gleaner combine, I can pick these up as well. It's a chopper belt off of a rotary. So really common parts that are going back on this thing. So first things first, I'm going to tighten these bearing collars down so that they won't move while I'm trying to do this. Okay, so I managed to drive the pulley onto the shaft here. Now it's time to chop off the extra drive shaft that we don't need. To do that, I got my angle grinder. And it's just that easy. So now we got that taken care of. Next thing would be to do is reassemble the fan itself. So to do that, we'll go around to the other side, see what that entails. Before we do that though, you can kind of see now how this belt tensioner system is going to work. This is just a rear idler. The front shaft is turning like this. So it's pulling down on that belt, which is obviously turning the fan. Goes back to the rear idler and then up to the tensioner that actually tensions the belt. Loosen that nut up, slide it down. That puts full tension on the belt itself. I am going to put another support here and eventually encase this whole thing in some sort of guard to make it look a little more professional than belts going everywhere. But that's where we're at. Let's go ahead and seal this back up. Alright, so we're going to attempt to put this on. Okay, so let's see the progress that's been made here. Finally have all of the belt tensioners in place. As you can see, well, really the only thing I got to do down there yet is I have to tighten up the end nut there that's on the drive shaft. Impact guns on the Charger at the moment, but as soon as I get that, we'll be in business. But at any rate, I put in some bracing here so that when we get some torque out here, everything stays where it ought to be. This unit, it'll be spinning in this direction, the shaft will be turning forward. And as you can see, everything seems to be in good alignment, so maybe might be running a little close on the back edge of that, but all in all, we're in good shape. So now, time to turn our attention to the ducting. The original air duct, it had a piece of aluminum tubing that went from here back to the back corner, and then since this was gearbox drive, this was on there at a 90, so then it piped it up another 90-degree elbow and came over. Anyway, that's laying over there in front of that gooseneck. I don't know if you can see it from here, but yeah, it was crushed as well. So what I did is I went out to everybody's favorite website, the Amazon, and was able to track down some, I guess it's made out of PVC. It's that clear ducting they use for dust collection systems. So it's about the same thickness as this. I don't think we're going to be in too bad a shape with it. Keep getting attacked by these, what they are. They look like ladybugs, but obviously they're not. They stink like mad when you crush them. They are all over this fall. Get off on that old ducting. So, kind of ignored that this one had the other hose clamp on it. That's what I get for throwing it. Alright, now we'll go get our dust hose. Alright, Judgment Day here, folks. It's time to go see what all of this hard work has done as we start 2024 soybean harvest. Clear the trailer. There we go. This is one of my disastrous fields. This first little chunk here is what had some woodchuck damage. The little guys were hungry this summer, I guess. Whatever. Can't say I've ever seen it this bad. Separator, gauge our head.